Hi, it's Moser with a quick tutorial on binary ionic compounds, naming them and writing them. After this video, you should be able to name any binary ionic compound when you're given the formula, and write the formula for any binary ionic compound when you're given the name. You already need to know what anions and cations are, as well as being quick and fluid and familiar with the ions that are made by the main group elements. Let's get started. So this video is serving as your introduction to chemical formulas, and we'll give a brief overview, but then we're going to concentrate on the ionics. For molecular compounds, a chemical formula shows the actual number of atoms in each molecule. But we don't have that luxury with ionic compounds because, of course, there are no molecules. So the chemical formula for an ionic compound is in fact a formula unit. And what that does is show the ratio of cations to anions in the ionic solid. Now, we're going to start off talking about simple ionic compounds that are made with monatomic ions. You know that mono means one, and monatomic ions are ions made up of a single atom. The main group, that's the S and P block, tend to lose or gain electrons to achieve a noble gas configuration, which you already know. And those atoms are now ions, having lost or gained electrons. So, groups 1 and 2, and 13, tend to lose electrons to form cations. Groups 15, 16, and 17 tend to gain electrons and form anions. And the D block is kind of their whole own weird thing. We'll cover that in a couple videos. Now, to know how to name a binary ionic compound made up of monatomic ions, it's really important that we know how to name the monatomic ions. And we're going to start with the simple monatomic anions and cations. Cations, boy, this couldn't be easier. Na1+ is called the sodium ion. Very creative, I know. Calcium 2+ is called the calcium ion. Wow, are you seeing a trend here? Yeah, we just name the atom and then we slap the word ion after it. Now, that goes for the cations. Anions are handled a little bit differently. We drop the ending of the element name and we replace it with this suffix, IDE. So a chlorine atom, which has gained an electron, becomes a chloride ion. The sulfur atom, which has gained 2 electrons, becomes a sulfide ion. Oxygen, 2-, is the oxide ion. It seems like a minor little thing, but pay careful attention to that IDE. It's going to become very, very important when you get a little further down the road into the polyatomic ions. So somehow make a special note to yourself that the IDE only relates to monatomic ions. You'll need to remember that. The D block, though it's mentioned on this slide, we're going to handle later. What you need to know is that those transition elements form multiple ions, things get complicated, and we name them appropriately. That'll be handled in another video. So, when you're given the formula for a binary ionic compound, that's something made up of 2 pieces, bicycle, it's really easy. Name the cation, name the anion. There's your compound name. So NaCl is sodium chloride. Al2O3 is aluminum oxide. And CaBr2 is calcium bromide. It does not matter what these little subscripts are. MgF2, well, I assume you've got your periodic table out. If not, let's go ahead and pull it out. To name this compound, we simply look at the 2 pieces. This, of course, is a magnesium ion, and this is fluoride. Therefore, this compound is magnesium fluoride. Again, the subscripts don't matter here. They will later, but they don't here. I doubt you need much more practice with this, but there are plenty of them on the practice sheet. Now let's get to the slightly more complicated bit, which is writing formulas when given names. You're definitely going to need your periodic table, make sure you've got it, and you should probably also grab the reference sheet that was given to you or is linked on the Chapter 7 plan. So we already mentioned that binary ionic compounds are made up of two different elements, and actually I should say two different ions. And we're starting off with simple binary compounds made from monatomic ions. In a binary ionic compound, the total positive charge has to equal the total negative charge to balance out. So magnesium 2+ forms a binary ionic compound with bromine, which is a 1-. We need 2 bromines for every 1 magnesium to balance the charges. Now, this is simple algebra, though there are some other methods that we'll talk about in a second. Let's practice with aluminum oxide. So we know from our reference sheet and our periodic table that aluminum tends to form a 3+ ion and oxygen tends to form a 2- ion. Well, some number of aluminums times the positive 3 would be equal to some number of oxygens times the negative 2. Well, we know that 2 times 3 equals 3 times 2. And the subscripts come from there. Let's do a slightly larger and more in-depth run through that. So given this compound, calcium chloride, well, the first thing we have to do is write down the ions that go into this. So we know that this is a calcium ion, and we know that this is a chloride ion. What charges would each of those have? We know that calcium is group 2, so it's going to tend to give up 2 electrons, and we know that chlorine is group 17, so it will tend to gain 1. That gives us calcium 2+ and chlorine 1-. So we're looking for our subscripts. Some number of calciums times that positive 2 will equal some number of chlorines times that negative 1. Well, 1 times 2 and 2 times 1 give us subscripts of 1 and of 2. This gives us a formula of Ca1Cl2. However, we never show a 1 as a subscript. The fact that the name of the ion is written there tells us there's at least one of it, so the 1 is unnecessary. The formula for calcium chloride, therefore, is CaCl2. Do you want to practice one more? How about potassium oxide? Well, we know that this is potassium with some charge, this is oxygen with some charge, and if we look at our periodic table, potassium is, of course, in group 1, so it tends to give up 1 electron, making it K1+. Oxygen is group 16, meaning it tends to gain 2 electrons, and we get oxygen 2-. Well, again, we know that 2 times 1 will equal 1 times 2, and that gives us our subscripts. So our formula is K2O. Remember, we don't write the 1 because the fact that the symbol for the ion appears tells us there's at least one of it. Now, let's talk about how you may have learned to do this earlier in your chemistry career. You may have learned something called the crisscross. Write down your ions, crisscross the charges down here to make the subscripts. It's really easy, admittedly, it is. The only concern is that you don't understand what you're doing. You're just finding a ratio between ions. You're welcome to use the crisscross. It's a great shortcut, but it's important that you recognize what you're doing. You're finding a ratio, and you're doing that using simple algebra. So, you're welcome to take the shortcut and crisscross, as long as you promise me that you will always remember what you're really doing is finding a ratio. Okay, go to your practice sheet, complete all the examples that you've got there, and check your key. When you're done, you've got a little FIP quiz.